Welcome to the AI Research Roundup. I'm Alex. Today we're looking at a paper from the Hugging Face trending list, published on January 28, 2026, just 2 days ago. It introduces a framework called Idea2Story that shifts autonomous scientific discovery from expensive runtime reasoning to offline knowledge construction, allowing agents to retrieve validated research patterns from a graph of over 13,000 papers instead of starting from scratch. The paper is titled Idea2Story, an automated pipeline for transforming research concepts into complete scientific narratives. And as we'll see shortly, the results show that this approach significantly reduces hallucinations and computational costs compared to existing agents. For those interested in the implementation, the authors have shared their code on GitHub. Figure 1 outlines the entire Idea2Story framework, which is split into 2 distinct workflows to optimize performance. On the left, the offline knowledge graph construction phase ingests papers from top conferences, breaking them down into reusable method units to build a structured map of scientific knowledge. Then on the right, the online retrieval-driven narrative generation phase takes over. Here, the system matches a user's rough idea to those established patterns and uses a review agent to refine them into a coherent research plan. So while Figure 1 gave us the big picture, Figure 2 zooms in on the specific steps for building that offline knowledge graph. It starts on the left with Stage 1, where raw papers and review artifacts pass through a funnel for anonymization and safety filtering. Then, Stage 2 deconstructs the content into 4 layers: the core idea, domain, story skeleton, and packaging actions. Finally, Stage 3 assembles these into the structured network on the right, connecting atomic method units and integrating reviewer feedback. So, having seen the pipeline in Figure 2, Figure 3 makes this concrete with a real example of an extracted method unit. Taking a paper on LLM fine-tuning, the system breaks it down into structured fields. First, it identifies the base problem. Here, the difficulty of tracing training influence. Next, it extracts the solution pattern, which describes the technical approach, distinct from the higher-level story and practical application. This structured format is what enables the system to treat research concepts as building blocks rather than just raw text. Alright, while Figure 3 focused on a single extracted unit, Figure 4 zooms out to visualize the resulting knowledge graph structure. The network follows a clear hierarchy shown in the legend. Large green nodes act as central hubs representing broad domains. These branch out into medium-sized blue nodes, which correspond to specific research patterns. Finally, the thousands of small red dots on the periphery represent the individual papers. This hub-and-spoke design allows the agent to efficiently traverse from abstract concepts down to concrete examples. So, having visualized the graph structure, Table 1 puts the system to the test in a head-to-head comparison. Both Idea2Story and a standard large language model were given the same vague prompt: I want to build an e-commerce agent. The middle column shows that Idea2Story generated intent diff, a proposal that creatively reframes classification as a diffusion process. In contrast, the right column shows the baseline's eco-intent, which falls back on conventional contrastive learning. Looking at the problem definition row, we see Idea2Story successfully shifted the paradigm to dynamic reasoning, whereas the baseline stuck to a standard multi-class classification setup. Wrapping up, 2 takeaways stand out. Shifting from runtime reasoning to offline knowledge construction drastically cuts computational costs, while grounding agents in structured graphs significantly boosts research novelty. This suggests that pre-built knowledge bases may be the missing link for reliable autonomous science. That's it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.